Graphing inequalities in two variables. When graphing inequalities, here's the first thing you do. You graph the boundary. Use a solid line for less than or equal to or greater than or equal to. All right. You use a dashed line when it's just less than or greater than. So the first thing you do is you graph the boundary. Second step is you use a test point. You pick a point, it does not matter what point. You pick a test point to determine which half plane should be shaded. Alright, if the test point is true, then shade that side. If the test point is false, then you shade the other side. This will make more sense when we see it on a graph. Write down this equation. It asks you to graph 3x minus y is less than 2. The first thing I want to do is make this slope-intercept form where y is by itself. Okay? Instead of an equal sign, we're just going to have a greater than or less than sign. In this case, it's a less than sign. Well, the first thing I want to do is I want to subtract 3x, so I'm going to move it over here. This gives me negative y is less than negative 3x plus 2. I can't have a negative y, so I make it positive, which changes the sign of everything else. Now I have this. Y is less than 3x minus 2. Sorry. Minus 2. Do we know how to graph y equals 3x minus 2? Yes. 3 is my slope. Negative 2 is my y-intercept. So do I know how to graph y is less than 3x minus 2? Yes, I treat it the same way. Right? Negative 2 is my y-intercept. So I graph my y-intercept first. It's the constant that's by itself. Negative 2 is not going to change. My slope is 3, which is the same thing as 3 over 1. So I go up 3 over 1. Up 3 over 1. Alright, do that a couple times and go backwards a couple times. Down 3 over 1. Down 3 over 1. Okay? Now I have enough that I can draw a line. But if you look at your rules, look on your rules from the last slide. Is this going to be a solid line or is this going to be a dashed line? Dashed. It says when you have less than or greater than, when it's not equal to, then it's a dashed line. So instead of drawing a solid line, I draw a dashed line through these points. Okay? It doesn't have to be great. It just needs to be a dashed line. You need to be able to tell that this is a dashed line. Now what I want to do is I want to pick a test point that's on one side. Okay, it doesn't matter what side it's on. It can be this side or it can be on this side. I just want to pick a point that's on one of these sides and I'm going to test it. I will tell you right now the easiest point is 0, 0. So what I do is I go back to my original equation, which is 3x minus y is greater than 2. I'm going to plug 0 in for y and 0 in for x. Is everybody with me so far? So I use 0, 0, this point right here. Okay, this point, it's on this side. I plug in 0 for x, 0 for y. Right? 3 times 0 is 0. 0 minus y is 0. Is 0 less than 2?
Oh my gosh, yes.
If it is true, if this point, 0, 0, is less than 2, then this is the side we shade. Meaning everything on this side is true to this inequality. You shade it, okay, just so I know that it's shaded. You don't have to make it perfect.
I'm going to color all the way in.
That's cool.
Do I want to shade this side? Guys, hush. Do I want to shade this side? No. If I had picked, let's say if I had picked 4, negative 4, would this have been a true inequality? No, it would have been false. So I would have wanted to shade the other side. Okay? Any questions? A line, the reason why it's a dashed line is because is the line included? No, because it has to be greater than the line, right? Okay, it has to be greater than the line. So a point on that line will not be true. Write this down. It says solve x minus 1 is greater than y. Y is already by itself. So do I need to move anything around?
No.
No. So my slope is going to be 1. My y-intercept is negative 1. So first thing I do is go to negative 1 on my y-axis.
No, one, no, one.
My slope is 1. Same thing as 1 over 1. So I put a dot 1 over 1 every time. Or I could go down 1 down over 1 every time.
It's gonna be dashed.
As Nick said, this is going to be a dashed line because my inequality is greater than, it's not equal to. So this is a dashed line. Alright. Someone raise your hand. Tell me a point that you want to graph, Shane.
0, 0.
Let's plug in 0, 0. So 0 minus 1 is greater than 0. Is negative 1 greater than 0?
No.
Is this a true inequality? Nick says no. Does everyone else agree?
Yeah.
Is negative 1 greater than 0? No, it's never greater than 0. So 0, 0 is not on the side that's included. It is the other side. So we graph this. Do what? If I had picked 0, negative 2, if I picked the y-intercept, 0, negative 2, would this have been included? Would a point on the line be included?
No.
No, because it's a dashed line. So Shane wants to know, what if I picked a different point? Okay, we can go 1, 1. It's clearly above the line, right?
Yeah.
You want a point that's clearly above or below the line, okay? Not right on it. So let's plug in 1, 1. 1 minus 1. Is 1 minus 1 greater than 1? Well, 1 minus 1 is 0. Is 0 greater than 1?
No. Honestly, change the y every time too.
Yeah.
Yeah. You see, my point here is 1, 1, right? My x is 1, my y is 1, right?
Yeah.
Let's pick a point that should be on this graph. I'm going to say 2, negative 2. So 2 minus 1 is greater than negative 2. 2 minus 1 is 1. Is 1 greater than negative 2?
Yes.
This is a true statement. So see why negative 2 is included in this graph? Why it's on that side?
I got a question.
Graph or draw this one. Alright, so let's graph this. First thing I need to do is get y by itself. So I'm going to subtract x. 5y is greater than or equal to 10 minus x. Okay, I'll switch it around in a second. This is you divide by 5, you divide this by 5. Y is greater than or equal to. What I do is I take 10 divided by 5. I take negative x divided by 5 as well. That leaves me with negative x divided by 5. Okay? Because negative 1 times x divided by 5, I just leave as x divided by 5. Okay? Or 1/5 times x. I take 10 divided by 5, which is 2. Alright? 10 divided by 5, which is 2. I switched them because I like to have x closest to y. Okay? But doesn't matter. Could I have went 2 plus 2 minus negative 1/5 x? No. It does not matter. I could do either one. What I do is I graph this. So my y-intercept is 2 because this, my b, is 2. This is negative 1 over 5. Means I go down 1 over 5. Down 1 over 5. So it's going to be slightly outside of that. So I go up 1 to the left 5. And, okay, it's going to be right in the middle of 10 minus 5. 10 minus x. Someone tell me, is this a solid line or a dashed line? Solid because of the equal to, right? Because it's less than or equal to, so it's a solid line. Someone pick a test point.
0, 0.
So 0 plus 0, is that less than or equal to 10?
Yeah. No.
Is 0 plus 0 less than or equal to 10?
It's not equal. I get it.
Change it.
It's less than. Okay? Or, remember the or equal to?
I got you.
So what side do we shade? Above the line or below?
Below.
Below, because 0, 0 is below. So we shade this side.
So our homework's gonna be easy.
Yes.
I was doing
What's your major malfunction? I don't know.
First thing here is I subtract x.
make X all positive.
So negative y is less than or equal to negative x plus 3.
Change all the signs.
I have to change my signs.
Negative.
So y is less than or equal to x minus 3. Alright, easy to graph. We go to the negative 3 on the y-axis. Up 1 over 1, up 1 over 1 every time. Bree, is this a dashed line or a solid line?
Dashed. Solid.
Solid because it's y is less than or equal to x,
Oh,
right?
yeah.
The equal to sign
Yeah.
makes it a solid line. So Hayden, pick a point. 0 what? 0 0. He wants to go with 0 0. Is there anything wrong with going with 0 0?
Yes, there's a lot of things wrong with it.
No, I like to go 0 0 because that means 0 minus 0. Is 0 less than or equal to 3?
Yes. It always will be.
No, it won't.
Yes.
In this case.
Caleb is, okay?
Alright, if he says so.
Okay.
Here's your assignment.